Okay, this is the second videos for 13.4 and 13.5. We are trying to find the definite integral, meaning we can actually find a number as my answer. This doesn't come with C. Alright, so the next one is similar to the last one we did, which we found the area under the curve and above the x-axis. And this one, they don't give you a graph, but basically it still means you're going to need to find the antiderivative and the integral, and then plug in the upper limit 3, subtracting the lower limit 1. Okay, so first we need to take the integral of that. So we are going to have let's see. We can pull out the 3 and then integral from 1 to 3 x squared dx, right? And then adding integral 1 to 3 e to the x dx. Okay, this is going to give us, we have the 3 here, the x squared will become 1 over 3 x cubed, right? And then the e to the x is just e to the x, and normally we will add c, right? So we can do it one more time and let you see. But after we take the integral, because this one come with the restricted area, right? So we go from 1 to 3, meaning we need to plug in 3 and then subtract, plug in 1, right? Like this here, right? Okay, so let's see. This one cancel, so basically it's just x cubed plus e to the x plus c, plug in from 1 to 3. So let's see, if I plug in 3, that would be 3 cubed plus e raised to the third power plus the c, subtracting 1 to the third power at e to the first power plus the c, right? So again, you need to use the upper limit, subtract the lower limits, okay? That will give me 27 plus e to the third power plus c minus 1 minus e minus c, right? So as you can see, the c always got cancelled. So if you're doing definite integral, a lot of time they don't even worry about the c. So we're going to have 27 minus 1 is 26. You have to be careful, e to the third power and minus e, they're not the same. It's like x cubed minus x. You don't combine them. So you will just write them out at e to the third power minus e. So that's your answer. So just be careful. We cannot combine these two. You can think about one of them is x cubed minus an x. They're not like term, okay? Unless they're multiplying together, then you can do it. Okay, so that's the example there. Let's do another one. So 1 over x, do you remember what that is? So again, this is the antiderivative of 4 subtract antiderivative of 2, okay? So 1 over x is the special guy. It means this is going to be ln of x plus c. After you take the integral, you don't need the integral sign, but you will write 4 and 2 here to remind yourself, right? So that would be ln of 4 plus c minus ln of 2 plus c, right? So ln of 4 plus c minus ln of 2 minus c. So again, if you don't want to write a c, that's perfectly okay. do we remember one of the property for log? If log, they're subtracting, you can change subtraction to division. So that's one of your competency exam question, right? So I can rewrite that as ln of 4 divided by 2. So this is actually ln of 2, or ln of 2 is positive, so you can just say ln of 2 is my answer. Okay? Alright, so it's not that bad yet. We have 3 more examples on the back, so let's do it. Anytime if you need to pause the video and catch up, please feel free to do so. Alright, the next one, this time is not ln of x, right? Because it's x squared. But again, we're going to use the antiderivative of the upper limits, subtracting antiderivative of the lower limits, like that. So, let's see. I can rewrite that as, this is from -3 to -1. This is x raised to -2 power, right? dx. Alright, so now we can take the integral. This would be 1 over -2 plus 1 x -2 plus 1, right? And then if you want to, you can add c, but after a while, hopefully you know that doesn't matter. But after taking the integral, I'm going to put -3 and -1 here. So that's the proper notation. So when you turn in your work, I would expect to see proper notation like that. Okay, so now we have -1, x raised to -1, plus the c, and then we're supposed to plug in these two numbers. So let's see. Start with -1, right? So this also means -1 over x, right? Can I just get rid of the c because it's going to cancel out? So plug in -1 and -3. So the first one will be -1 over -1, and then minus -1 over -3, right? Okay, what would that turn to be? So the first one is 1 minus 3. Hold on, not 3. 1/3. Okay, so that means 3 over 3 minus 1 over 3, right? So the final answer is 2/3. Alright? Hey, let me write this a little bit better. So this is 1 over 3. Okay. Alright. So hopefully you're okay with that. Let's see the next one. So again, we're using antiderivative of the upper limits, subtracting antiderivative of the lower limits. Alright. So this one have 2, 1. Pretty sure the first guy is ln, right? But the second one is like what we just did, -2, and the whole thing need to be dx. Okay, so after I take the integral, the first guy is ln of x, and then the second one we just did, right? So it was this guy, -1 x raised to -1 power, right? And then this thing need to plug in, upper limit is 2, lower limit is 1, right? Okay, now we got ln of x, and then 1 over x, plug in 2 and 1, right? So that would equal to ln of 2 plus 1/2, subtracting ln of 1 plus 1, right? Okay, what does that mean? Let's see. I don't know what ln is 2 is, so I'm going to write it down, plus 1/2. But if you use the calculator, ln of 1, where's ln? ln 1 equal to 0. So I can say minus a 0 and then distribute the negative, so -1. So we got ln of 2, and I have plus 1/2 minus 1 is kind of like plus 1/2 minus 2 over 2, right? So this is ln of 2 minus 1/2. Are we okay? So we're going to say note ln of 1 equal to 0. All right. Okay, so next we have one question like this on the homework, so make sure you know how to do it. So again, this means we're going to use the antiderivative of the upper limit 8 minus antiderivative of the lower limit 1, right? So I can rewrite this as integral 1 to 8 and 4 times x raised to what power? So a radical, this has a 1 here divided by 3, right? 1/3 dx equal to, I can pull out a 4, right? So 8 and 1 here, this is x to the 1/3 power dx. Okay, I need to take integral of that, so I need to be careful. 4 times, this is 1 over, I have 1/3 plus 3 over 3 plus 1, right? And then also x raised to 1/3 plus 3 over 3. And don't forget to put the upper limit and lower limit there. Okay, so what do we get now? So we got 4. I really should put the parenthesis here. Sorry about that. So the whole thing we plug it in, right? Let's do that. Okay, so now we got 4. This is 1 over, this is 4/3, and x raised to 4/3, and then need to plug in 8 and 1. So this is basically flip, right? So you get 4 times 3 over 4. Oh, that's good news. X 4 over 3, plug in 8 and 1, because I can cancel this, right? So basically, I have 3 x raised to 4/3, and then plug in 8 and 1. Okay, got it. Okay, finally, I think we can plug it in. Upper limit is 8. Need to raise to 4 over 3, and then subtract 3 times the lower limit is 1, 4 over 3. Okay, what is this? So if I have an 8 raised to a power parenthesis 4 divided by 3, I should get a 16, because this is to the cube root, right? Cube root of 8 is 2, 2 to the 4th power is 16. So either way, hopefully you arrive at 16. So 3 times 16 minus 1 to anything power is just 1, right? 3 times 1, meaning 3 times 16 is 48 minus 3. Final answer is 45. Okay, so it kind of tests you a lot of basic skills for math and also your integral skills and plugging it in. Alright, that's the end of that.